50 milliwatt, and the supply voltage Vi is given as 16 volt, right? So for that, I have told you to determine the values of VL, VR, IZ, and PZ. So can you tell me what are the values you are getting for VL? What is the value you are getting? What is the value of VL you are getting right now? Can you explain? Listen, you are already in some steps back for your mid-sem, right? So you have to be, active while solving these numericals. If you are going this much speed, then you are not going to cover all the syllabus before your semester at least. Are you getting my point or not?
Yes, ma'am.
8.73 volt. VL.
Very good. Who is answering?
Chiranjit Sahu.
Chiranjeev Sahu. Okay, I will. What is your registration number, Chiranjeev?
74.
74, right. Those who are answering only, they will get the marks, okay, for your daily performance. Rest you will get 0. You will get your attendance mark, but for daily performance you will get 0. Now,
Ma'am, I did, but I got 9.96 volt.
that is incorrect, because what is the value of current you are getting here by applying KVL?
KVL.
First you have to determine the value of current, right?
Yes, ma'am.
Current through the circuit. What is the value of current you are getting? What is the KVL equation you have put? What is the KVL equation you have derived from the circuit? What is the KVL equation you have derived from the
VI
circuit?
minus VR is, ma'am, VI minus VR minus VZ is equal to 0.
Minus Vz equals to 0. But whenever you are applying for your current, if you remember, the first step was to, what is the first step? What is the first step for your fixed Vi and RL? Step number 1. What was your first step?
Ma'am, VI minus
Ma'am.
IR minus VL equals to 0.
Why the VL equals to 0? Why there is VL? What was your first step? Step number 1 कौन लेखा ही थिला मने नहीं तो माने क्लास रे किछि नोट डाउन करू न
Ma'am, to determine the state of Zener diode.
Zener diode, then read the whole sentence. Determine the state of Zener diode
by removing it from the network and calculating the voltage across the
by
resultant
removing
circuit.
it from the network. By removing it from the network, right? So if you remember, in our first step, we represented the Zener diode as one open circuit. You have to remove your Zener diode to determine its state, whether it is in on state or off state. After that only you will apply your KVL. So when you open that one, only the remaining part is Vi, then your current limiting resistance will be there in series, and again in series that will be your load resistance. That is your whole circuit. Now Vz portion is your open circuited. So tell me, who else got the KVL equation?
VI minus IR minus IRL.
Minus IRL equals to 0. From that,
0.
Vi value is, what are the parameters in this equation, you know, that is known to you? What are the parameters in that equation that is known to you. What are the parameters? Which parameters are known to you? Vi known to you?
Yes, ma'am.
What is the value
Yes,
of
ma'am.
Vi? 16 volt, right? And what is the value of R given to you?
1 kilo ohm.
1 kilo
1
ohm. Very
kilo.
good. What is the value of RL?
1.2 kilo ohm.
Very good. So the unknown parameter is only I. So you can take common I. Then you can find out the value of current. Yes or no?
Yes, ma'am.
So what will be the value of current? 16 divided by R plus RL. That will be 1 plus 1.2 kilo ohm. So what will be the value we are getting for current? What is the value we are getting for your current?
Ma'am, 7.2 milliampere.
7.27 milliampere. Right? 16 divided by 1 plus 1.2. Kahar doubt roila ithre? Kahar doubt roila? Up to this much? For finding the value of current. All of you got the same value, 7.27 milliampere, or any deviation? All of you are getting 7.27 milliampere, or you are finding any deviation?
Yes, ma'am.
Same value.
Yes, ma'am.
Okay. What is your name? Tanisa Agrawal, right? What is your registration number, Tanisa?
Ma'am, 665.
665. Okay, next. That is the current value. Now, how will you find out your load, voltage drop across your load?
I into RL.
I into RL. Now, what is the value of I you are getting? 7.27 milliampere, and RL is known to you as 1.2 kilo ohm. By multiplying them, you can find out the value of VL. That will be 7.27 into 1.2. What will be the value? 7.27. Always remember the units. The current you are getting in which unit? 7.27 what? Ampere.
Milliampere.
Milliampere, correct. And 1.2
Kilo ohm.
kilo ohm. So the units will be into 10 to the power minus 3 into 10 to the power plus 3. So that will be cancelled out. So remaining will be, what is the value you are getting?
Ohm ampere.
Huh?
Voltage.
What is the value of VL you are getting?
8.72 volt.
8.72. What?
Volt.
Volt.
Volt. Very good. Miss Siddharth Das. Siddharth Das, what is your registration number? Okay.
ମ୍ୟାମ୍ ସେଟା 8.727 ବାଲା ସେଟାକୁ 8.73 ଭୋଲ୍ଟ ଧରା ହବନି କି?
You can round that one, 8.73 or 8.72, whatever it is your choice, right? So now what will be the state? How will you find the state? What is the state of your diode?
Offset.
Why it is off state?
Ma'am, since V is in the VZ value.
State habo. Ma'am, since V is
Wait,
less
I
than
will ask you
VZ is
one by
greater
one.
than V.
Okay, first Soumya Ranjan Panda, you told me the diode is in off state. Why it is in off state, Soumya? Soumya Ranjan Panda. Soumya Ranjan Panda, am I audible to you?
Yes, ma'am.
Rudra, why you are answering on behalf of Soumya Ranjan? Okay, I'm marking him absent. Okay. Soumya Ranjan Panda. Now, next I will ask to Saraswat. Explain.
Yes, ma'am. Yes, ma'am. Ma'am, VZ value, ma'am, greater ବାହାରିଲା V ରୁ ସେଥିପାଇଁ off state ଏଇଟା ଯିବ.
What is your VZ value?
Ma'am, VZ 10 volt ଥିଲା.
Right. VZ is given to you in the question, that is 10 volt, and V you have find is how much? How much V you have find? What is the value of V? Nishant, what is the value of V?
Ma'am, 8.73 volts.
8.73 volt, and your VZ is given as 10 volt. So obviously 8.73
Yes, ma'am.
is less than 10 volt. That's why you can find out the state of the Jenner
It is-
diode, that is off, right?
Off state.
Very good. Now,
Yes,
as the
yes,
diode
hello.
is in off state, then what will happen? Soumya, don't interfere now. Whenever I was calling your name, you are not there. You were not there, right?
Sorry, ma'am.
Very good.
Ma'am, the voltage across
તમે કોડી
RL
થીલો first
will be.
কথা? Why you are not replying? Why you
Sorry,
are
ma'am.
not replying? That person is covered. I have got the answer why diode is in off state. Now we are proceeding to the next level. Okay. Now you have find out in the first step, you have find out the state of the diode, as well as you have find out the current value and the voltage drop across the load. That much portion is covered now. Now, as diode is in off state, it means whatever the step number 1, the circuit we have designed, that will continue. Yes or no? That will remain in the same state, because in the step number 1 also we have just considered the diode is in off state, right? Because we have taken it as our open circuit. Yes or no? So what is the step?
Yes,
Yes,
ma'am.
ma'am.
What is the step number 2 given to you? Can you explain? What is the step number 2?
Ma'am, substitute the approximate equivalent circuit and solve for desired unknown.
Trupti, very good. What is the registration number, Trupti?
Ma'am, 676.
Huh. So for your हाँ सौम्यरंजन
मैम
हाँ
मैम VL टा भूल हबो ना से कहला I into RL
I into RL हाँ कम मैं भूला बा
सिर्फ IL into RL I का
why
डिवाइड हो
I
जाएगी
why I is dividing
पैरेलल
कोई
कनेक्शन
अच्छा तमे को केस टा यूज
मैम
करूछ right
VL
now.
भाग कर
No, I'm just
ऑफ
asking को case use करूछ. Both are fixed, right? Fixed VI,
Yes,
fixed RL. At that time, we are taking the step number 1. What was your step number 1? You are removing the Jenner diode from the circuit. While you are removing the Jenner diode from the circuit, जदि रिमूविंग कर देइछ तो सेठी कोन होउची सेठी किछ अछि कि पैरेलल पाथ रो किछ रहिला जेनर डायोड ता ही तो तमे रिमूव कर देइछ.
yes ma'am
The first step, follow the whatever I am telling you consecutively. You have to follow those steps, right? So your step number was step number 1. What was given to you? If you remember, तमु जानिन तमे note down करिसो कि नहीं? I'm just repeating that sentence. Determine the state of the Jenner diode by removing it from the network and calculating the voltage across the resulting open circuit, right? Can you confirm
Yes, ma'am.
this one to me, Trupti? This was the statement, yes or no?
Yes, ma'am.
Right. So while you are removing it from the network, then there is nothing in the parallel path. Right? So the current will flow through VI, then your current limiting resistance, that is R, then across RL, then again back to VI. Yes or no? So there is no concept of double current there. There is no nodal analysis because there is no node itself. Because across this BZ path, there will be no current flowing. Right?
Yes, ma'am.
Clear? Soumya, clear?
yes ma'am
Right. So we are next moving to the next step. What was our next step? Already we have determined our diode is in off state. Next step was what? Substituting the approximate equivalent circuit, right? What will be your equivalent circuit while diode is in off state? While diode is in off state, what will be the equivalent?
Ma'am, open circuit in the
Open circuit in the place of your Zener diode,
Yes, ma'am.
right? So now that
Yes,
is
ma'am. Yes, ma'am.
that is one open circuit. We have already drawn that circuit in our step number 1. Setai koriche to step number 1 right?
Yes, ma'am.
Yes, ma'am.
So now you will find out your desired unknown. What is your desired unknown? कौन कौन पचारिथिला question रे? VL, VR, IZ, PZ, right? So as
Yes, ma'am.
Zener diode is in off state, what will be your value of IZ?
0.
0. Very good. And you have find
Zero.
out your VL value. Now can you find out the VR value?
Yes, ma'am.
What will be your VR value?
Ma'am, 7.27 volt.
Right, because current into 1 kilo ohm. Current is 7.27 milliampere and your resistance value is given 1 kilo ohm. So that will be 7.27 volt.
Yes, ma'am.
Right. So now we are coming to our PZ value. What will be your PZ value?
Ma'am, 0
Power
watt.
is rated for
0 watt.
0 watt, because PZ equals to VZ into IZ, where IZ is equals to 0. That's why that will be 0. Right? Now, anything left?
Yes, ma'am.
So all the parameters have been covered? Yes or no?
Yes, ma'am.
Now, what was your step number 2? What was your step number 2? Right. Repeat step number 1 with RL equals to 3 kilo ohm. Right. So now again you have to repeat all those steps. So step number 1 was find the state of the diode, right? By removing it from the network. Again follow the circuit. You can follow the same KVL equation. What was the KVL equation? What was your
Ma'am,
KVL
V equal
equation?
to RL.
What was the KVL
V equal
equation?
to
I'm asking?
RL VI by R.
Sorry, repeat. KVL equation. Kirchhoff's voltage law. KVL equation.
V equal to I VI by R plus.
Sorry, Rudra, can you repeat? You are not properly audible.
V
Can you
equals
repeat?
to RL VI. V equals to RL VI by R plus RL.
V equals to R. No, I'm just asking the equation. Directly give me the equation. What will be your
VI
KVL
minus
equation?
IR minus IL. VI minus IR minus IRL equal to 0.
Rudra heard this one? Chiranjeev कौन कहला
Yes,
सुनी
ma'am.
पारलो? हाँ. So are you getting my point or not? तमे KVL equation टा जानी पारुचो ना जानी पारुनो?
हाँ मैम जानी
जानी पारिचो? काହାର डाउट अछि यदि एबे भी पचारो. यदि डाउट अछि then already you can ask me right now. If you are having any doubt, you can ask me right now. Because this was very easy question, right? We are discussing right now. But while you are giving your exam, the level of the question will be little difficult, right? So if you are not getting this question, then that will be really difficult for you to clear your midsem. That's why I'm telling you repeatedly. If you are having any doubt, you can ask me right now. ସେତେବେଳେ କଣ କରିବ? No, you have to write that you are applying wherever. Listen, in the exam, you have to derive it step by step, right? So for that, you have to write what is your what rule you are applying. Whether you are applying your KVL or you are applying your KCL or you are going for any voltage divider rule or anything, you have to mention that statement first. We are applying KVL in this loop. Loop number 1 or loop number 2, you can given that name, right? So after applying KVL in this loop, we are getting this equation. So you have to first write that equation. Then you have to find out from that equation we are deriving our I, because if that is not required, then mu tumko step by step bujhe hi na thandi, mu direct formula hi kahi de thandi, right? So as we are keeping in record, so that's why you have to, in the exam, you have to explain in the same format. Okay, first you have to write that we are applying KVL in this loop. Then you have to write this is the KVL equation. What is the KVL equation? Vi minus I into R minus I into RL equals to 0. From that, you can put your values. Vi equals to 16 volt in place of Vi. You can write down your 16 volt. So the equation will be 16 volt minus I into R is 1 kilo ohm minus I into RL is equals to 3 kilo ohm. That is equals to 0. From that, you can find out your I value. I will be 16 volt divided by 1 plus 3 kilo ohm. Correct? Correct or not? Are correct or not? Because that is Vi minus IR minus IRL equals to 0.
Ma'am, again,
Listen, I'm just showing you the same circuit. Okay. This was our step number 1. What we have to do? We have to remove this VZ. We have to remove this VZ from here. Right? Then this will be the circuit. Yes or no?
Yes,
This is
ma'am.
the circuit, right? So values are already given. What you have to do is you have to apply KVL. What will be the loop? Vi into this will be your I into R. Now again, by using this RL path, it will come back to, this is the loop. Eta loop hobo to? Current
Yes,
path
ma'am.
eta
Yes, ma'am.
hoga na nahi? Because eta open circuit hai gala. You are removing this Zener diode. Right? Removing the Zener diode. Removing it from the network. Right? It means your Zener diode. It means is your Zener diode. Right? Removing it from the network and calculating the voltage across the resulting open circuit. So we are finding this path, right? So what will be your equation? Vi minus IR minus I into RL equals to 0. Yes or no? From there you can find out your I equals to
Yes,
Vi
ma'am.
divided by R plus RL. Now this is known to you. Vi is 16 volt divided by R is equals to 1 kilo ohm plus 1.2 kilo ohm. Right? From there you can find out your value.
No, ma'am. Sir, 3 kilo.
Kete? 16 divided by,
Ma'am, 3 kilo.
sorry,
3 kilo.
right, correct. Thank you very
1
much.
kilo. 1.
So now this is step number 2. We are getting 3 kilo ohm, right? So 1 plus 3 kilo ohm. 16 divided by 4 kilo ohm. So that will be 4 milliampere. बुझी पारलो ना बुझी पारलोनी एबे भी डाउट रहिला
Clear, ma'am.
No, ma'am.
clear. So now go to the second step. So now you have to find out the state of the Zener diode. You are getting 4 milliampere. So what you have to find out? Open circuit path re kete अछि voltage. So open circuit re voltage kete asibo?
Ma'am, 12 volt.
12
12
volt.
volt.
Now you have to find out this V equals to VL. That is your open circuit path. We have to find out voltage across the resulting open circuit. Voltage across this resulting open circuit will be same as our VL. This open circuit re jete ki voltage drop hobo, eiti bi same voltage drop hobo parallel path re. Somyaranjan, are you getting
Yes,
or
ma'am.
not? So now, Somyaranjan, are you getting or not?
Yes, ma'am.
So now you have to find out V. So V will be equals to VL. Correct? Saraswat,
Yes, ma'am.
are you getting or not?
Yes, ma'am.
Okay, so that's why we are finding the VL value. VL will be same I into RL, because open circuit there will be no current flow. Current flow will be in this path only. So I into RL. I already you have determined the value 4 milliampere. I into RL value you can put. RL is RL is now 3 kilo ohm, right? Now it is 3 kilo ohm. By using this you can find out your VL. VL will be 4 into 3, 12.
12.
12 volt.
volt.
Now you have to find out the state. V less than Vz, then diode is off. V greater than equals to Vz, diode is on. Vz is 10. Vz is given as 10.
Yes, ma'am.
Right, as Vz equals to 10 volt. Now you are getting V equals to 12 volt. So 12 volt is always greater than 10 volt. So diode is in on state.
On state.
Now you will go for the on state analysis, right? So if on state, what will be the equivalent circuit? This one or this one?
Second one.
This one or this one?
Ma'am, the lower one.
The lower
Lower
one,
one,
right?
ma'am, down.
V is greater than equals to Vz. Now diode is in on state, means you can represent this with one voltage source, right? So in this circuit, you can apply
Yes,
your
ma'am.
KVL. If you apply your KVL, then this will be Vi minus, here there will be two current concept. Jota tame pacharuthilo, Soumya. Now are you clear or not?
Yes, ma'am.
Because here the diode is in on state, right? So if it is in on state, you can directly put Vi minus IR into R minus Vz equals to 0. From here you can find out your IR value, right? Kete aschi? Now what will be the value of Vz here? What will be the value of Vz here?
10.
10 volt.
So now put the
Ma'am,
value.
I have to 6 question.
Sorry, can you tell me? What is the value of IR you are getting?
Ma'am, 6 volt.
6 ampere.
6 ampere. कि ओटा तो 6 volt कहलेनी.
Milliampere.
Sure, 6 million.
6 milliampere. Very good. Now what is the value of IL?
And 3.33 milliampere.
3.3 milliampere.
That is 3.33 milliampere, right? Now what is the value of IZ?
2.67 million.
2.67 milliampere.
2.67 milliampere. सब find out करूचो ना एंदी मने मने कहि दोचो.
Ma'am,
Now what is the value of PZ here?
And
What is
Vz
the
into
value of
Iz.
VZ into IZ? So what is the value we are getting?
26.7.
26.7 milliwatt.
Milliwatt. So can you tell me, is this one correct or not? Is it applicable or not?
Applicable, ma'am. Applicable.
Applicable. How? Because PZM is given to you as
30 milliwatt.
30 milliwatt. So that comes under this range, right? So it is
Yes, ma'am.
one applicable value. So this much portion is covered, right? तबे नेक्स्ट जहाँ भी क्वेश्चन देले करि परिबो ना करि परिबोनी अलगा जेते बडे वेरिएबल VI वेरिएबल RL वाला क्वेश्चन देले करि परिबो
Yes, ma'am.
so write down okay mo तुमको लास्ट क्लास एंड I will share the question in the group. Okay, you have to find out, then we will discuss it in the next class. Okay, करके आनथिबो सब. Now we are going to rectifier. Okay, all of you are having your separate basic electronics notes, yes or no? You know that thing, na? Right? You have to submit your class note at the end. Are you aware of this thing?
No,
Are you
ma'am.
aware of this thing or
No,
not?
ma'am. No, ma'am.
No, ma'am.
Listen, you have to submit your class notes as according to your dates and etc. તમે जो date रे present अछो and जो date रे class notes नहीं छ, you have to write down and you have to submit that one at the end. Scan करके तुमको submit करिया को पड़िबो classroom रे. Okay, I will share you the classroom link where you have to submit your assignments as well as your class notes. Okay.
Yes, ma'am.
Then same in the same classroom we will provide you the quiz and surprise test, everything. Okay, there will be one quiz test. You know segmentation તમે જાણીଛ ના જાણીનો કોણ કોણ ટેસ્ટ હબો કેમતી માર્કિંગ હબો જાણીଛ ના નહીં?
None take question.
કઈ દઉં સુનો તમે ફર્સ્ટ your attendance will carry some mark. Okay, attendance marking haba even if it falls below 75%, then you are not going to appear your exam. Okay, whether it is your mid sem or your semester. Okay, mid sem pai bhi evaluation till date ra haba, right? Means before the mid sem that will be your evaluated as 75%. Okay, then after your mid sem means from the very beginning of your day 1 to at the end of the class. Okay, total ra evaluation haba semester pai. ठीक है, अटेंडेंस रो बिलो 75% तुम एग्जाम दे पारिबोनी, राइट? सेकंड इज योर डेली परफॉर्मेंस बेसिस रे मार्किंग हबो. ओके, नाउ थर्ड इज you will appear one surprise test and one quiz test. Okay, that will carry some mark. Then your assignment will have 5 marks. Okay, then your class notes will have 5 marks. Okay.
Yes, ma'am.
Clear? So say हिसाब रे evaluation हबो. So quiz test हम mid sem परे आमे करिबा, ठीक अछि? I don't want to put any load before your mid sem, so just concentrate on that one. After mid sem we will go for the quiz test as well as our surprise test. Okay, 5 marks. So then we will go for our assignment evaluation and our class note evaluation. Okay. No.
Ma'am, medicine question type केमती रहइबो?
Question type subjective type ही most probably रहिबो, right? And another thing is the syllabus for your midsem is BJT configuration. Okay, configuration of BJT. Okay, up to that much it will come. Okay, so we are yet to cover all these portions. So we will start with our rectifier now. Then after rectifier we will come to BJT. Okay, and another thing, if possible, Sunday Sampath sir will take one extra class for you. That will be okay for you? Because Saturday, Sunday consecutive chutti achi.
Yes, ma'am.
So Sunday sir karo gote class rakha habo, extra class. So sir will cover that part. Okay.
Okay, ma'am.
So let's come to
assignment करिबो मैम एटा हम नॉर्मल कॉपी रे करिबो कि से लूज शीट्स रे करिबो मैम?
assignments को तमे गोटे नॉर्मल कॉपी बस गोटे बहुत पतला कॉपी गोटे परचेस कर दियो, सेइथिरे करिबो assignments. Okay, तो assignment 1 I will share in the group today itself. Okay, then total 3 assignment दिया हबो, 1 2 and 3. 1 I will provide you today. Okay, up to rectifier. Up to rectifier, that will be your assignment number 1. After rectifier, assignment number 2. Okay.
Okay.
Okay, so let's start. So take your notes simultaneously. Okay. So first of all, why this rectifier? Listen, we have already studied diode and Zener diode, isn't it? So diode, the application of Zener diode, you have gone through your voltage regulator. Yes or no?
Yes, ma'am.
Now for the diode application, there are so many applications of diode involved, right? One is rectifier, clippers, clampers, voltage multipliers, right? Different type of circuits are there where you can use your diode. Okay, but in your syllabus only rectifier portion is there, right? Clipper, clamper, voltage multipliers are not there. Only rectifier portion is there. So we will study for that one only. Okay, how this diode is involved in our rectifier circuit. Okay, so before coming to this rectifier portion, I will just revise you through some portions. Okay, in our AC, what is your AC current, DC current? You know, right? What is
Yes,
AC
ma'am.
and DC, right? So if I represent one AC value or AC voltage in one waveform format, then how will I represent one AC voltage?
Sine wave.
Sine wave. So mathematically,
Yes,
I
ma'am.
can represent this like this. Represent that sine wave like this. Vt equals to Vm sine omega t.
Yes, ma'am.
Is it
Yes,
correct
ma'am.
or not? Right. So just ଟିକେ recall ଖାଲି କରୁଛି ମୁଁ ତମକୁ already ତମେ mathematically ଜାଣିଛ ସବୁ. So what will be the value of Vm, means what is the representation of Vm here? Why this Vm term is involved?
Maximum voltage is being used.
Maximum voltage, or you can say
Yes,
that
ma'am,
is the
maximum.
amplitude, peak amplitude value, isn't it?
Yes, ma'am.
Right.
Yes,
Yes,
ma'am.
So now sine omega t. What is this omega?
Angular frequency.
Angular
frequency,
frequency.
that can be written as our 2 pi f
Two-
angular
2 pi by
frequency.
t.
Yes, ma'am.
I'm coming to that. 2 pi f, or you can say 2 pi by t. Yes or no? Because frequency equals to 1 by t.
Yes, ma'am.
Yes, ma'am.
Right.
Yes, ma'am.
So now you can represent this in as Vt equals to Vm sine omega t. Am I correct? Correct or not?
Yes, ma'am.
Yes, ma'am.
Yes.
Yes, ma'am.
Now this much, this is the sine wave. एभलिया represent करूजो. So this is our time axis, and this is, in this axis we are taking our V value Vt. So this will be our Vm maximum amplitude. ठीक अछि तो?
Yes, ma'am. ठीक है.
Right. So gote cycle,
Yes.
how much time it is taking for one cycle? 0 to how much?
4 second. 4 second.
4 seconds.
Second.
No, ma'am.
Or you can
Ma'am.
say 2 pi, right? 2 pi or pi?
Pi.
2 pi.
2 pi.
2 pi, ma'am.
2 pi, ma'am.
2 pi, right? So now if I take the average voltage over the time period, it will look like this. V average will be 1 by t integration of 0 to t Vt dt. Am I correct or not if I take the average? Yes or no?
Yes, ma'am.
Yes, ma'am.
Right? Correct achi na nahi? Whenever you are
Ma'am,
taking
it
your
is very
average,
clear, confused.
whenever you are taking your average value, tomorrow V value is given to you, Vt is given to you. So if I go for the average of this one, I guess basic mathematics, this one, average value whenever you are taking, that you will take your integration. Yes or no?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
So V average will be 1 by t integration, limit tends to 0 to 2 pi. Sometimes you are taking, or 0 to 2 t. I am taking here 0 to t. T means you will consider 2 pi, right? 1 by 2 pi integration of 0 to 2 pi Vt dt, or here you will put your sine omega t, right? Here is 2 t is nothing but your 2 pi. You can take your 2 pi. Correct or not?
Yes,
Yes,
ma'am.
Yes, ma'am.
Yes, ma'am.
Or you can say directly, I am just taking in the format of t itself. So it will be Vm by t integration 0 to t. In the place of Vt, I am just putting sine omega t dt.
Yes, ma'am.
So now you can solve. I guess you know more mathematics than me. So you can solve it, right? Integration of sine omega t will be
minus cos omega t by omega.
Minus cos omega.
T divided by minus cos omega t divided by omega, and limit tends to 0 to t. Limit varies from 0 to t, right? So you can solve this one. Vm divided by t in the place of Vm divided by t. Now this omega, I have just opened this bracket, right? So I have just placed this omega here. Vm by omega t. Remaining is minus cos omega t plus, means upper limit minus lower limit, right? In the upper limit, I have put t equals to capital T minus cos omega t plus cos 0, because minus of minus cos 0, right? That will be plus cos 0.
Yes,
Yes,
ma'am.
ma'am.
Plus 1.
So now, in the place of omega, we will put 2 pi by t. In the place of omega, we will put 2 pi by t. Now in case of omega, you will put, already we have discussed, जोटा मैं लिखितली ऊपर जंती scroll करके देखली, same thing, 2 pi by t, right? So you will put in
Yes,
case
ma'am.
of omega here 2 pi by t, right? So if you put 2 pi by t, t cancel out, remaining is 2 pi.
Yes, ma'am.
Yes, ma'am.
Right. Here also you will put, in case of here is also one omega is there, Vm by omega t. In case of omega, you will put 2 pi t, 2 pi by t into t. So t cancel out, remaining is 2 pi.
Again.
Yes, ma'am.
Yes, ma'am.
Right.
Yes,
So in
ma'am.
this, here it will, remaining is 2 pi. Now here it is also remaining 2 pi. Cos 0, you know that thing. Cos 0 equals to 1, and minus cos 2 pi will be minus 1. So the remaining is Vm divided by 2 pi whole into minus 1 plus 1. So this will be 0. 0 into anything, that is 0. So therefore, the average value of an AC voltage over the time period of oscillation is 0 normally, right? So this is the basics we have decided. We have just covered. Now coming to the main topic, that is our rectifier. Okay, now we will come to our rectifier. Okay, so basically we will start with there are, if I go for the rectifier, what is rectifier? Do you know what is rectifier?
Ma'am, it basically rectifies the signals. I mean, the waveforms.
How it
Ma'am,
rectifies the
AC को I think DC रे convert करियो rectifier.
in general layman language, you can say AC to DC को convert करियो, but the basic you can write, you know, this correct thing, that is, it is a device which converts a sinusoidal waveform having 0 average value, right? Having 0 average value to a unidirectional waveform, or you can say DC waveform with a non-zero value, right? So I can say this is rectifier. Okay, I'm repeating, it is a device which converts a sinusoidal waveform having 0 average value. Why 0 average value? We have just discussed. Average value coming 0, right? Just discussion kale. Average value
Yes,
0
ma'am.
asutila ki nahi?
Zero.
So 0 average
ma'am.
value
Zero.
to an unidirectional waveform, or you can say DC waveform with a non-zero value, Now there are two types of rectifiers are there. One is
Ma'am, I think full wave rectifier and half wave rectifier.
Halfway.
very good. One is half wave rectifier and one is full wave rectifier. Now there are two types of full wave rectifiers as well. So what are the full wave rectifiers? One is full wave bridge rectifier. One is full wave bridge rectifier and one is full wave center tapped rectifier. Okay. Center tapped rectifier. In some books, you will see classification half wave and full wave. In some books, there are other type of classifications are there also. One, they will call it as bridge rectifier. One is center tap rectifier. In the bridge rectifier, they will classify half wave and full wave. Are you getting my point? This half wave is also one type of bridge rectifier. Okay. This half wave rectifier is also one bridge rectifier. Okay.
Yes.
हमने टिके टिके पढ़ियो ना नहीं केल्विन ब्रिज ये सब टिके टिके पढ़ियो ना नहीं
जानि
जानि
छ पढ़िथिलु हाफ वेव फुल वेव
Yes, ma'am. Half wave, full wave, and bridge.
Right. So there are classification book accordingly different है पारे. Half wave, full wave नहीं कि हमें differentiate करी परिबा. Or in some books it is bridge rectifier and center tap rectifier also. So there is no problem with that. That much you know, right? So coming to the half wave rectifier, we will see how it looks like. Okay. So first we will see half wave rectifiers, right? So why this is called half wave rectifier? The main thing is why it is called as half wave rectifier. जो तुम्हें पढ़ी चुकी है कहलो कौन पाई?
Use of only one Zenor diode.
One Zenor diode.
Ma'am, half of the only half of the wave, not the
right. Only one half of the input AC is rectified and other half is zero, isn't it? This is the sinusoidal waveform, right? Total time period I have taken is T. So half portion will be rectified, only half. Okay. Half portion will be rectified. The other half will be zero. That's why it is called as our half wave rectifier. Right. So basically, amar kamo kono sinusoidal, as we have already discussed, this will be like this will convert AC to DC. तमे जेमती कहलो. So how it will be AC to DC? Normal AC signal looks like this sinusoidal waveform, and DC signal केमती आसे? DC signal केमती आसे? Straight line. Straight line generally rahega katha, but some in the rectifier you will get pulsating DC. You can say you will get pulsating DC type, right? Like this. Okay. So how this DC will come, we will see. Okay. So now in our AC, if I state the AC signal, as we have discussed, the total time period is 0 to T, and this will be T by 2. 0 to T, and जोड़ा में already PDF रे देख ले, and this will be T by 2, and this is our VM, right? So what I am saying is, तो तुम्हारा one half of the signal will be rectified, right? And another half you will get zero in the half wave rectifier. So how it will occur, we will see, right? Coming to the half wave rectifier, we will see. So this is the basic circuit of our half wave rectifier. One diode, PN junction diode, is also called as our crystal diode, right? Or you can say semiconductor diode. Okay. Simply this PN junction diode or your crystal diode, okay, is being used here, and that is connected to one resistance R. Okay. Excuse me. That is connected to one resistance R. Okay. Now the voltage supply, the input voltage supply is given in this direction, and this is the output. You will take the output voltage across this load or across this R resistance. Clear? मैंने already पढ़ा तो तुम इधर जानी चाहिए, right?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
So now what I am telling you is, So is this the correct circuit or not? ठीक अच्छी circuit. Generally, our rectifier is always associated with one. What is this?
AC supply.
Transformer.
Transformer. This is already associated with our transformer. This is the circuit for our representation of our transformer. Why this transformer is used? Because whenever you are going to provide our AC supply directly, transformer काम कौन application कौन? Step up, step down transformers पढ़छो ना नहीं?
Yes, ma'am.
So this will provide one step down application. Okay, whenever you are providing our AC supply, that will be very huge value, huge voltage value, 220 volt supply. Yes or no? So that will provide one step down application. Okay, so that will be one step down voltage will be provided here as input to the rectifier circuit, right? Rectifier पे एतिक input हमको दरकार नहीं, 220 volt supply दरकार की rectifier को गोटे खाली diode लगी across one resistance, right? So that will be that will provide the step down application, and it will provide some protection also, all right? Protection to the circuit. That's why we are using generally गोटे transformer सहित rectifier circuit associated thai. So same thing, we will just analyze this much portion. Okay, we will just analyze this much portion. So coming to here that will be your transformer circuit is also there. Acha tame jete exam re karibo, you can draw this circuit, then coming for the analysis just go for this diode and resistance part only. There is no need to extra calculation या ପାଇଁ ଦରକାର ନାହିଁ କିଛି, ତ ଆମେ ଖାଲି এই output side रा calculation ଟା check କରିବା. Here you will come it will come vi v equals to vm sin theta or sin omega t, right? हाँ ना नहीं?
Yes, ma'am.
Yes, ma'am.
So
Yes, ma'am.
coming to this circuit, now input is like this, one sine wave vm sin omega t. Yes or no?
Yes, ma'am.
Now this is our input voltage
Yes,
that is provided here. Now we will see in the first half or in the positive half. Okay, if this is the positive half is given, then what will happen? Whenever the positive half is there, then positive half means here it will be the positive value, positive Vm value, because this is plus Vm and here it is minus Vm. This one, correct or not?
Yes, ma'am.
So then it
now-
gives the positive output also.
Right, you will see here you are getting positive Vm here. It means this potential is positive potential. Positive potential is connected to the positive terminal of the diode. Yes or no?
Yes, ma'am.
Yes, ma'am.
So
Yes,
the
ma'am.
diode will be in which condition?
Forward biased.
Forward
Forward
biasing
biased.
condition. Now current flow will occur through this diode. Yes or no?
Yes, ma'am.
So now
Yes, ma'am.
current flow will be in this direction. Then
Yes.
through the resistance, right? So if you go for the KVL analysis, then what will be the KVL equation? What will be the KVL equation? Like this you will check. So this will be VI minus IR equals to 0, because here you will
Yes,
just
ma'am.
diode is giving nothing, right? खाली direction ही दउची forward biasing रे अछि. So जदि तमे एठी किछि small resistance नबो, if we are taking which condition? If we are taking our approximate model, equivalent model of the diode, can you recall that one? Approximate, simplified, ideal.
Yes, ma'am.
Yes, ma'am.
So जदि हमें सेठी approximate model analysis करिबा, then there will be some resistance value RF. Yes or no?
Yes, ma'am.
Yes,
So
ma'am.
if
Small
there is
value.
nothing given to you, simply it will be VI minus IR equals to 0. Am I correct or not?
Yes, ma'am.
Yes,
Now
ma'am.
what will
Yes,
be
ma'am.
your value of V naught or V output here? V output will be
IR.
IR, right? And that is your input as well, because from this equation you can say VI equals to IR.
Yes, ma'am.
So whatever your input is, that is same as our output. VI equals to V naught. VI equals to V naught. I can say that one. Yes or no?
Ma'am,
Huh?
ma'am, the diode ର resistance ନଥିବ, then only in this case V naught is equal to VI is equal to V naught.
Yes. If resistance value is given, then or even just 0.7 volt drop भी ହେଲା, ताहले कौन होगा? That will be a little less, but that comes in the positive direction also. But टिके ही less value आसो, same thing होगा. VI equals to IR minus something value, right? So that is negligible. That's why we are taking the same value, or else it will come a little less. Okay.
Yes,
So,
ma'am.
So what you are getting here, VI equals to V naught, right? That is the positive half. Okay. Now coming to the, okay, that thing I have already given here. Okay, you can take the screenshot whenever the positive half is taken, right? 0 to T by 2 is taken, right? This much is the only positive half. So V naught you are getting as VI. If VI, as we have already seen here, हमें कौन नौचे? VI रो positive half टा खाली नौचे, right? Positive half खाली नौचे, हाँ ना नहीं?
Yes, ma'am.
So same thing you will get here. In the output, we are getting the same value. Okay, we are getting the same value, right? VI equals to V naught. And here, as this diode is in forward biasing condition, you can represent this with one short circuit path. Yes or no?
Yes, ma'am.
Now, coming to the negative half, coming to the negative half. Okay. Now we will put this negative half. Negative half means minus Bm. Yes or no?
Yes,
Minus
ma'am.
Bm or no? So here minus Bm will be applied, right? Minus Bm will be applied. So we will see what it will look like. So as I have already told you, minus Bm will be applied here. So if minus is connected, minus potential or negative potential is connected to the P terminal, then this diode is in
Reverse biased.
reverse bias HMI diode. So reverse bias means you can represent this with one open circuit.
Yes, ma'am.
So no current will flow across this circuit,
No.
right?
No.
So this will be so कौन आसिबो? Value 0. V naught will be 0. Yes or no?
Yes, ma'am.
So you are getting nothing in the negative half. You can see here one straight line is coming. V naught equals to 0 volt. Clear?
Yes, ma'am.
Yes, ma'am.
So combiningly,
Yes.
it will look like this. Combiningly, it will look like this, because at the positive half of the input, here I have taken VI input. Input voltage look like this. Combiningly, we will represent the output. For the positive half of our input signal, you are getting the same, that is our Vm, and for the negative half, we are getting 0. Again, at the positive half, you will get some value. Again, at the negative half, you are getting 0. Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So,
Ma'am.
huh?
Ma'am, PPS class my link challenge.
Okay. Just hold on for 5 minutes. Okay.
हाँ मैम कॉल लेता हूँ 10 minutes late हो बोले.
Okay. So now I can represent mathematically. You can represent like this: V naught T equals to the output voltage for the half wave rectifier. V naught T I can represent for the positive half from 0 to T by 2. That is the positive half, 0 to T by 2. Right? We are getting Vm sin omega t, because that is our input, and for the T by 2 to T, that is the negative half, you are getting 0 value. Mathematically, we can represent like this. Yes or no? Am I correct or
Yes,
not?
ma'am.
Yes, ma'am.
Yes, ma'am.
So for there, you can find out your average output voltage. Your average output voltage, you will take like this VDC. You can represent your average output voltage is VDC, okay, or V average. You can say this is V average is equals to VDC. Okay, to calculate average voltage VDC of the pulsating DC. Why it is called pulsating DC? You know that thing, right? We have already discussed, because it comes like this. Straight line thodi asuchi. Pulsating hai ki asuchi, which will act as our straight line. So we can call this as pulsating DC, right? So just I'm telling you, the pulsating DC output of half wave rectifier, we can use this method. This method means already जोटा हमें करिथिले, जोठी average calculate करूथिले, right? Here we were discussing our average. एटी करथिले ना, 0 आस्थिला sine
Yes,
wave
ma'am.
ପାଇଁ.
Yes, ma'am.
Yes, ma'am.
The same method you will apply. तमे जानिଛ average केमती calculate करिया को हुए, right? So normal for average you will take 1 by t integration of limit varies from 0 to t v naught t dt. Now we are taking for the output. For the output you can represent, now एटा को हमें दुईटा segment रे divide करि परिबा. For the positive half it is Vm sin omega t, and for negative half it is 0. Yes or no? For positive half
Yes,
we are
ma'am.
getting the same as input. So for the positive half 0 to t by 2, I am taking Vm sin omega t dt, and for the negative half, that is t by 2 to t, I am taking 0 dt. Are you getting my point or not?
Yes,
Doubt
ma'am.
ରହିଲା.
Yes,
मैम
ma'am.
आउ
Yes,
थोड़ा
ma'am.
टिके कहू
ଆରେ
Yes,
ତମର ଏମିତି ଆସୁଛି କି ନାହିଁ, ଏମିତି ଆସୁଛି କି ନାହିଁ ଆଉଟପୁଟ ଭୋଲ୍ଟେଜ ଟା?
ଆଜ୍ଞା
ତ ଏଟା କେତେରୁ କେତେ ଯାଏ ଆସୁଛି? 0 to t by 2, and t
ଆଜ୍ଞା
by 2 ରୁ capital T ଯାଏ 0 ଆସୁଛି, ହଁ ନା ନାହିଁ? ହଁ ନା ନାହିଁ?
यस मैम
ଏଠି ଦେଖ, ଆଉଥରେ ମୁଁ କହୁଛି ଏଠି ଦେଖ. See, this is 0 to तम टाइम लिमिट साइन वेव रो 0 to एटा गोटे साइकिल की नहीं, एटा t, ठीक अछि?
यस
एउठ एतिकी t on then t off. So ए मझिटा कोन हबो? t by 2. So up to 0 to t by 2 you are getting some value Vm. तो नेगेटिव हाफ रे तुम 0 वैल्यू पाउचो, हाँ ना नहीं? So up to
Yes, ma'am.
0 to t by 2 you are getting the same as Vi, right? t by 2 to capital T जाए 0 पाउचो.
आज्ञा
Same thing टा represent कराइछि Vm sin omega 2 0 to t by 2, then t by 2 to t it is 0.
आज्ञा मैम
So same thing we are moving here. So same representation heichi. You can check 1 by t 0 to t by 2 Vm sin omega t dt, 1 by t t by 2 to t it is 0 dt, right? t by 2 रो t जाए 0, t by 2 रो t जाए it is 0. बुझी पारलो ना नहीं?
हाँ मैम बुझा
Now just keeping this value you can solve this one. This will be Vm divided by t integration 0 to t by 2 sin omega t dt, because it is already 0, right? Right or not?
Yes, ma'am.
So remaining portion is this much you will calculate for only the positive half cycle. So Vm you can take this constant value out. You can take this out, right? Constant value. So this will be Vm by t. Remaining is integration of sin omega t dt. Limit varies from 0 to t by 2, right? So same thing for sin omega t, integration of sin omega t, that will be minus cos omega t divided by omega, right? And the limit is 0 to t by 2, right? Only positive half. Now Vm by t, here it is the omega, taking outside omega t, Vm by omega t. Now this will be minus cos omega t by 2 plus cos 0. Now t by 2, here omega equals to 2 pi by t. Apply omega equals to 2 pi by t. So if you put here 2 pi by t, omega equals to 2 pi by t into capital T. So t cancel out, remaining is 2 pi. Yes or no? Yes or no?
यस मैम
Here again omega equals to,
Yes,
you will put 2 pi by t into t by 2 is there. So t cancel out, 2 cancel out, only pi is remaining. Cos 0 equals to 1, and cos pi will be cos pi.
-1
1.
So कौन आसिला value? Here it is कौन आसुची वैल्यू यू विल पुट हियर टोटल टा केते आसुची ब्रैकेट भितरे यू विल गेट हाउ मच वैल्यू 0
2 ma'am.
you will get
2.
2, right?
Yes ma'am.
So now so here it is 2 and here it is already 2, right? 2 cancel out hijibo. So remaining you will find Vm by pi. You can check whether you are getting the same value or not.
Yes ma'am.
Vm by 2 pi.
Yes,
Here
ma'am.
it is Vm by 2 pi into 2 cancel out. Remaining is Vm by pi.
Minus 1 then 1.
ठीक अछि?
Yes ma'am.
Yes.
So you can follow this one. Okay. Okay, for the next class we will
Yes
see
ma'am.
for the RMS value calculation. Okay.
Yes ma'am.
Okay, let me take the attendance, then you can leave. Okay. Sonal Satpathy, quickly attendance there. Sonal. Om Prakash. Om Prakash absent. Sachidanand Raut. Sachidanand
Present,
Raut.
ma'am.
Subrat Bhuya. Nikita Priyadarshini.
Present, ma'am.
Tapas.
Present, ma'am.
Priti Parimita. Haris.
Present, ma'am.
Ayush Swai. Ayush Swai. Sudipta Nanda. Sudipta Nanda. Arpita Sahu.
Present, ma'am.
Som Saurav.
Present ma'am.
Saraswat.
Yes ma'am.
Chiranjeev.
Yes ma'am.
Sitish. Soumyaranjan Singh. जो मनकर अटेंडेंस हो जाउची दे कैन लीव. Sitish. Absent. Soumyaranjan Singh. Subhasish Chaudhary.